Next session, this is about focusing on AI. We know it's going to transform our industry at incredible speed. We've been speaking about that for the last 2 days. But actually, it's the need to adopt that AI mindset that is also important, isn't it? So to talk about this and much, much more, please now welcome Paul Clark. He's CTO from Ocado.
Good afternoon. Right. So in 1957, a psychologist named Frank Rosenblatt, working at the Cornell Institute for Aeronautics, built a machine that he called the perceptron, which could perform simple image recognition. It used a 20 by 20 array of photocells connected to some artificial neurons, and it was modeled on the human brain, and rather than being programmed how to recognize images, it learnt how to recognize them. And this was arguably the birth of the neural net, and given the subsequent experiments that he did on multi-layer perceptrons, it was arguably the birth of deep learning too. Roll forward nearly 70 years, and in March 2016, the world was shocked when DeepMind's AlphaGo beat Lee Sedol, one of the best Go players in the world. However, the really significant event was yet to come. AlphaGo had been trained on 100,000 games played by humans. But then in 2017, DeepMind created AlphaGo Zero that learnt from scratch by playing itself armed only with the rules of Go. In a matter of days, AlphaGo Zero was better than its human-trained predecessor. And then before DeepMind shut down the research program, they published the outcomes of 50 AlphaGo Zero games. These games contained moves that no human player had discovered in over 2,000 years of playing the game. It's as if for those 2,000 years, human Go players had been exploring only part of the Go problem space. And just like early land explorers, thinking that their maps represented the whole territory. Then along comes AlphaGo Zero and says, look at all this other territory that you've never explored. After being beaten by AlphaGo, Lee Sedol was initially depressed about being beaten by a machine. But then he realized that he could learn from AlphaGo, and he used the new moves that AlphaGo had discovered to raise his game. And for me, this is a great example of how AI offers the opportunity to augment and coach us. AIs can help us evolve as a species, I believe. Now, there's no doubt that the technological planets are aligning. The Internet of Things, cloud computing, big data, robotics, electric vehicles, drones, artificial intelligence, and many others. And this intersection is driving the evolution of smart mobile machines that are powered by clean energy, that are aware of the world around them, and that are able to interact with it. That are able to interact with one another and with us. Machines that can collaborate and swarm like insects, sharing what they learn about their environment to harness the power of the crowd. And to help bring this to life, I want to talk a bit about the future of mobility, because I believe it is incredibly significant not only to the future of supply chains in the last mile, but also to smart cities. For me, the future of mobility is about this smart, distributed, interconnected ecosystem. It's about vehicles powered by electricity, hydrogen, and possibly other clean fuels. It's about advances in the enabling technologies such as batteries, motors, 5G, LiDAR, microprocessors, and many others. It's about autonomy and the basket of AI technologies that makes that possible. But it's also about the intersection, collaboration, and orchestration of all manner of different autonomous machines, including cars, delivery vehicles, drones, and robots. And sitting on top of this mesh network or ecosystem of autonomy will be a host of smart services delivering the efficiency and service level gains, unlocking the network effects, disrupting traditional business sector models, addressing the scaling challenges and providing monitoring and oversight, keeping us safe from accidents and other threats, and so on. Autonomous, clean energy-powered vehicles are going to transform and disrupt the movement of all sorts of atoms around our planet. Across sectors, for example, in factories, hospitals, and construction sites and homes. Across supply chains in the last mile. On roads, pavements, cycle tracks, railways, and under the ground too. On and under the sea, in the air, and even in space. In cities, rural communities, and extreme environments where humans would rather not tread. But this is not just going to be a technological transformation, it's going to involve significant business model disruption too. Logistics companies will become taxi firms and vice versa. Postal companies will become retailers, and retailers may perform delivery and collection services on behalf of other companies. Car manufacturers will become internet search, entertainment, and accommodation providers. Hotels and other businesses with inner city properties may provide services for the storing, charging, servicing, and dispatch of car sharing and autonomous vehicles. Automated hubs that store customer orders close to the last mile will enable us to move from a push model, where goods arrive when you're out, to a pull model where they arrive on demand just in time when you want them. And this will be a Russian doll model of autonomy. Planes and trains and ships will hand off to large vehicles to smaller ones, small vehicles to swarming vehicles or drones. And the final 25 meters will become the domain of the robot, either dispatched from a swarming vehicle or robots that live in your building that you trust and which understand the navigation of your local space. But it's not just the machines that are going to have to get smarter about how they collaborate and play nicely with one another. So must we. We need to evolve new models for collaboration across sectors and across missions, including between would-be competitors. Because if everybody just carries on doing their own thing, we will not make the best use of our finite resources, such as energy, time, land, and transportation network bandwidth. At the same time, we will fail to minimize the unintended consequences, such as pollution, congestion, accidents, and waste. Roads full of half-empty, single-minded autonomous vehicles will not be a good outcome. We have to find ways to harness the network effects associated with shared vehicle ownership and multimodal vehicles that can carry people and goods. And without wishing to sound too fantastical, these vehicles may even need to be able to adapt themselves like transformers. We need to create a smart, open ecosystem that encourages cross-sector optimization, where startups and established players can evolve smart services to drive greater efficiencies and consumer delight. We need to learn what role smart infrastructure may play in this future. Imagine walking around an airport that you've never visited before, which has had all the signs removed. You probably could find your departure gate eventually, but clearly the signage really helps. Similarly, a little bit of smart infrastructure may make autonomous vehicles cheaper, safer, and more efficient. There's no doubt that the technological challenges we face could be reduced if overnight we replaced all vehicles with autonomous vehicles, whether that be on land, sea, or in the air. They could communicate with one another, trust one another, be more predictable in their behaviors, be centrally orchestrated, but clearly that's not going to happen. So autonomous vehicles are going to have to be smart enough to contend and coexist with their human-driven counterparts. And that means that as the percentage of autonomous vehicles increases, we will eventually reach a tipping point where, ironically, they can become more stupid again. To help us get over this tipping point, we need to consider what communication and sensing we may need to add to conventional vehicles in order to help them play nicely with autonomous vehicles and with the supporting infrastructure. Making these autonomous vehicles efficient, safe, reliable, and sustainable is all about harnessing the basket of technologies in the AI family, including machine learning, deep learning, reinforcement learning, image processing, natural language processing, statistical analysis, and so on. But it's also about the underlying data. Data about roads, maps, and traffic conditions, weather and roadworks, data about what the vehicles around you are doing and planning to do, data about what has happened in the past to drive dynamic risk assessment, and many others. So we need to find ways to share these data via data marts and common standards, not only to enable control and monitoring, but also to foster research. We need to find ways to get miles on the virtual clock as well as the real one. And here the role that simulation and digital twins can play is so crucial. Not only can they help us evolve and test algorithms, technologies, and services safely before they're released into the wild, they can help us even generate data to train machine learning models before the real data exists. It's therefore no surprise that driverless vehicle companies have been using computer games to train their models and subject them to unintended and unanticipated challenges. But we also need to foster more real-world learning too, learning about the intersection of autonomous vehicles, drones, smart infrastructure, robotics, and smart services, learning about the interaction of people with these technologies, learning what it takes to make a smart, automated city really hum. And that's what Google decided to do when it came up with the concept of Sidewalk Labs in Toronto. This is a bold plan to create an incubator for innovation within smart communities and cities in order to kickstart the learning and to share the outcomes with the rest of the world. For example, affordable housing, sustainable living, and a stronger sense of community, all supported by sensing, data, and smart services. But we need to do this in the UK too, and Ocado is hatching some exciting plans to do just that. When crystal ball gazing about the potential impact that these technologies will have on the future of work people, we often draw parallels with the Industrial Revolution and how some jobs were transformed, others disappeared, but new ones were created. Unfortunately, the lessons from history may not be useful when forecasting the disruptive transformation that we now face, and the reason is the nonlinear nature of AI. AI enables you to do the really exciting things with other disruptive technologies. Without AI, a robot is arguably just an expensive pile of electromechanical components, and that's why AI is the smart glue within the Industry 4.0 family of component technologies. AI can discover, or at least unearth, knowledge that has been hidden to humans because of factors such as complexity and bias. But most importantly, AI is a recursive technology. You can use one generation of AI to help train the next, more advanced one, enabling it to evolve much faster than does human intelligence. So when it comes to disruptive technologies, AI really is, in my view, the one to rule them all, at least until perhaps quantum computing knocks it off that perch. Now, like other disruptive technologies, AI can be a huge force for good, helping us solve some of the big problems that we have created for ourselves. As mentioned already, AI can help us make smarter use of our scarce resources. AI can help us improve our physical and cyber security, and smart agents can help us safely navigate a world increasingly awash with sensor data as the IoT revolution rolls on. AI can help us reduce or hopefully reverse the impact of challenges such as climate change, pollution, and poverty. AI can help us generate insights, manage complexities, and make discoveries that are beyond our human minds. AI can help us tackle major societal challenges such as scalable and affordable remote medicine and providing healthcare and maybe even companionship for our growing elderly demographic. In terms of the impact on consumers, it's still early days in terms of the AI adoption cycle. Consumers have yet to get a real taste for it, but when they do, they will demand that all of their products display this new level of smartness, and they will expect them to play nicely and smartly with one another. AI offers consumers the possibility of saving time, reducing friction, greater personalization, avoiding mistakes, increased security, improved service levels, and so on. Now, the advent of cloud-based AI services has completely democratized access to AI. It's made it a commodity, and in so doing, has redefined the baseline for smartness. Now, for a few cents, you can call a cloud service, pass in some data, and get back a smart prediction or insight. How applications and services take advantage of this new smartness will become an important source of differentiation. But along the journey towards this smart future, there are going to be some bumps or potential bumps in the road. Because an ideological war is raging between the optimists, such as myself, and the dystopians in terms of predicting how our AI-powered future will play out. Listening to this debate, one could be seduced into thinking that we have a choice about whether or not to embrace technologies such as AI and robotics, but we don't. The UK may be an island, but we cannot afford to behave as such. The technological tide is coming in all around the world, and playing King Canute will simply not end well. What we do have a choice about is how to make the best of the opportunities in front of us and successfully navigate the inevitable transformation challenges along the way. We also need to strike the right balance between legislation and innovation. If we get this balance wrong and unduly throttle our innovation, then countries who prioritize innovation will have the advantage. Legislating against a future that some may fear could lead to unintended consequences that could be much more unpalatable. Applications of AI and robotics pervade Ocado's end-to-end e-commerce fulfillment and logistics platform, but I only have time today to touch on a few of them. Our customers are typically shopping for a basket of over 50 items, and many are shopping more than once a week. It would be amazing if they woke up and said, "Today, hooray, today is my online grocery shopping day," but I promise you they don't. And the reality is, this is something they just want to complete in a few minutes. But there's a conflict here, Because on the one hand, it's about helping our customers shop faster and with less friction. But on the other hand, we want to surprise and delight them and inspire them with all of the other products they might like to buy from our 50,000 item product range. And this is akin to the products that are in your peripheral vision as you rush around the aisles of a conventional supermarket with your trolley. And we need to personalize our service to fit the needs of individual customers, and this means that our user interfaces have to be smart. We need them to adapt to whether the customer is new or experienced, to their different shopping styles, to whether they are doing their full shop or a top-up shop, and so on. So you could say that Ocado is really in the time travel business. We're about giving customers back the time that they would have wasted traipsing around a conventional one-size-fits-nobody supermarket. But our vision goes much further than this. It's about creating a smart broadband of grocery where the right groceries turn up at the right time, as if by magic, without you even having to order them in the first place. Now, a key element of our platform is the first mile, where our customers get to place and manage their orders. And last year, we launched our first conversational interface, the Ocado shopping skill for Amazon's Alexa. This skill enables our customers to perform actions such as adding and removing items from their basket, checking the cutoff time for editing their order, checking what time their order will arrive, checking what's in their order or its total value, and so on. But much more importantly, this skill is just the first step in a much bigger journey towards conversational interfaces in voice hubs, connected cars, chatbots, smart appliances, voice-enabled mobile apps, call center, and so on. However, we don't want our customers having separate, disjointed conversations on different devices and platforms. For example, you might order some mangoes in your kitchen using Amazon Alexa. Then you get in your car and decide that instead of the ripen-at-home variety, you want the ready-to-eat variety. So you contact Ocado again, but now perhaps it's using a plugin for Microsoft's Cortana or Google's Assistant that's built into your smart car. And when you refer to the mangoes again, you need the plugin to realize that it's the same mangoes you ordered 5 minutes ago. So we're busy building a conversational engine to power these sorts of conversations across multiple different endpoints, with access to all of the rich customer data and context that we maintain. And this engine will also provide personalized learning for each customer. When you ask us to add milk to your order with no further qualification, then which of the 100 different varieties of milk that we sell are you most likely to be referring to? In our newest warehouse, you will find swarms of robots gathering the groceries from our customers' orders. Imagine a giant chessboard, and on that chessboard, there are robots that, like rooks, can move along rows and columns. And under every chess square is a stack of storage bins containing groceries. The robots can stop on a square, lower a grab, pick up a bin from the top of a stack, and bring it up into the body of the robot, and then move to another square to deposit the bin. Or they can bring the bins to special machines around the edge of the grid, such as a pick station, where a human, or indeed another kind of robot, can pick groceries from the bin into a customer order. Or a decant station, where products arriving in from suppliers are deposited into bins and then into the grid. We call these hives, and our warehouses typically contain 2 of them, one for ambient product and one for chilled. These hives can be several times the size of a football pitch each, with thousands of robots swarming around them. In these hives, there are 3 levels of machine learning at work. There's the intelligence we're building into the robots themselves for the purpose of self-test, troubleshooting, and exception handling. So if they have a problem, how do they wiggle their fingers and toes, so to speak, in order to find out what's wrong, either to fix the problem themselves so they can rejoin the swarm, or else go into the pits for a service. This local intelligence also opens up the opportunity for swarm-based learning, just as it will for autonomous vehicles on the roads. Then there's the real-time orchestration and optimization of the robot swarms and their associated grocery storage. This is performed by a complex machine learning-based air traffic control system. There's the 2D optimization of the movement of the robots themselves, and then the 3D optimization of the storage grids underneath them. But we're performing this optimization looking forwards in time, so it's really a 4D optimization problem. Where's the best place to put back a bin of cucumbers based on when you'll next need it? And the answer to that question is changing all the time as new orders come in from customers and new bins of cucumbers arrive from suppliers. Now, we're going to have swarms of thousands of robots in every facility, and we're now building many such facilities both for ourselves in the UK and our Ocado Smart Platform customers around the world. And there's no way that human engineers can possibly look after the monitoring and oversight of these swarms scalably and sustainably. So all of the data exhaust from these robots is being streamed to the cloud, and here we're building the third level of intelligence, a machine learning healthcare system that keeps the members of each swarm in tip-top shape by spotting the onset of problems before they become problems. This is directly analogous to what we can do in terms of remote medicine for humans, using data from wearables and other sensors in the home. And this is also a great example of AI enabling us to do something that is completely beyond what humans could achieve. But we're also familiar with the challenges of robots sharing their world with humans. We have a Horizon 2020 project where we're building a humanoid maintenance robot called Second Hands, which rather than being taught what to do, learns by observing human engineers at their tasks and works out how to collaborate with them. And we will use this not only to help automate the maintenance of our facilities, but potentially one day to automate their construction too. Now, one of the most exciting applications of machine learning for me is when you attach a machine learning application to a simulation of the real world and let it loose to discover new strategies, solutions, and paradigms. In the case of AlphaGo Zero that I mentioned earlier, this simulation was obviously of the game of Go. In our case, we build high-fidelity simulations, emulations, and visualizations of our business, which we use to test new algorithms, test production software before we deploy it, evolve new machine learning models, and play back production data for troubleshooting purposes. And we're very excited about attaching machine learning models to these simulations, and then, like AlphaGo Zero, allowing them to explore new ways to optimize our end-to-end processes. But where is all this going? Well, there are many other applications of AI and machine learning across our platform, such as fraud detection, product forecasting, processing unstructured data, analyzing product damage, optimizing delivery routes, and so on. But eventually, we want to build an Ocado brain, or in the 2001 A Space Odyssey sense, an Ocado HAL, a general AI that understands our business model, that understands our data taxonomies, that has oversight of our end-to-end platform, an AI that can answer questions about our business, that can help us work more efficiently and make less mistakes, that can act like the third gyro on an aircraft, spotting the onset of problems that are about to impact us, that can help coordinate our suppliers, that can help our customers shop faster, with less friction and greater delight, and so on. Now, obviously, that sort of general AI is beyond the current state of the art. So we're currently focusing on building individual pieces of that puzzle that we will join up over time as the AI technologies and computing power advance. For us, the current outcomes are much less important. What is much more important are the learnings and competencies that we acquire along what is now firmly for us an AI and robotics first journey. Now, one of the key challenges that the UK faces in responding to the opportunities related to AI and robotics is the skills deficit. And robotics and AI lie at the most overheated end of the software engineering skills spectrum. And there is massive shortage of graduates and postgraduates emerging with these skills. But what is not talked about enough is the fact that these skills lie at the end of a digital literacy pipeline that stretches all the way back to primary school. That is why 4 years ago at Ocado we launched our Code for Life initiative, where our engineers volunteer their time to create a completely free online resource to help teach digital literacy in schools. Code for Life is now being used by over 130,000 students across 100 countries, and you can find it at codeforlife.education. But true digital literacy is much more than just teaching kids to code. For example, we also need to teach them to be data literate, to understand how to organize and manipulate data, to gain insights from them, to visualize them, to build models from them, to understand the dangers of bias, and so on. We also need to help our children understand the amazing possibilities and current limitations of technologies such as AI and robotics, the important ethical and philosophical questions around their applications, what it means to be human, and so on. However, this pipeline must not stop at college or university. It needs to continue on into the workplace, and here we need to do much more to incentivize organizations to invest in continual learning, particularly when it comes to subjects such as AI and robotics. We need to fuzz the boundary between education and work life. We need to prepare children for the process of continual learning and the inevitable reskilling that awaits them. We need to teach self-reinvention as a meta skill and to reframe the midlife crisis into an art form. Many of the skills and techniques we are currently teaching our children will be as devalued in the years to come as the encyclopedia has been by the advent of the World Wide Web. Instead, we need to focus on teaching enduring meta skills, such as collaboration, creative thinking, problem solving, intersectional thinking, mind mapping, goal setting, innovation, and entrepreneurship. I believe if we enable our children to leave school having learnt how to learn, full of curiosity, armed with a set of future-proof skills, and with a joy of ongoing learning, then they will be well equipped for their life ahead. So I believe we need to completely rethink our education system from the ground up, and in so doing, future-proof the underlying curriculum. But it's in situations like this that our 5-year democratic term does us no favors, because the scale of the transformational change we now face in order to respond to the challenges and opportunities presented by technologies such as AI and robotics cannot be addressed by short-term thinking. To address these challenges, there is a need for much bigger and more disruptive thinking by government, industry, and society at large. But coming back to Ocado to finish, our underlying technologies know almost nothing about grocery, and so they have many exciting spin-off applications. So a key part of my role is now to look for opportunities to use these technologies to disrupt all sorts of other sectors, some of them very far from the online grocery tree. So ultimately, I believe that we are on a mission to help change the way that the world stores, sorts, assembles, moves, and sells atoms. And so there's obviously quite a lot to do there. Thank you very much indeed.
There's one slide. Paul, thank you very much indeed. Fascinating stuff. I know that we have a couple of questions for you before you leave.
Yeah,
Would that
fine.
be all right? So let's look at that. We're talking about deep learning. Has it made it possible for people without computer science degrees to make meaningful contributions to AI?
I think that, there's the part at the center, which is about, building the underlying kind of AI basket of technologies, which of course is, primarily a computer science or software engineering challenge. Mm-hmm. But as I've been trying to say, there's a lot of things around this, whether it be around, marshalling the data that you need to train the models, whether it be about, the design of systems that use machine learning and AI, whether it be about, coming up with the new business models to make the most of it. So it's far from being just about, being a computer scientist. And I think this is one of the challenges we face, is how do we widen people's idea, not just of what technology can do, but how it touches so much of our lives, but also how you can be a part of it. Mm-hmm. And it's not just for the geeks and the computer scientists. It's really something, and that's why I think we need everybody to have a level of digital literacy, if you like, that is going to equip them in their future lives.
Absolutely. So that comes back to the education system, but of course,
absolutely,
that takes time, doesn't it, to kick in? Okay, and your background, I think people would be really interested just to hear briefly about your journey of how you got to where you are today.
Crikey, if I can remember. So I'm a physicist by origin. I studied physics, and but I think spent most of my physics degree trying to find ways to use computers. I nearly actually dropped out of university and to do a first startup, and I was always waiting to do a first startup, and then I had a computer in my study, and spent most of my holidays trying to earn money to buy new computers and things, and then I went straight into the computer industry, and after a couple of years did the first startup and carried on and done a bunch of different things, and then 13 years ago got a call from somebody at Ocado and nearly put the phone down on them because they said it was about retail, and I said, well, I'm not interested in that. And then they persuaded me that actually it wasn't normal retail, and sure enough, it isn't. And the rest, is history. So I fell in love with the place and stayed over there ever since.
Wonderful. Okay, well, thank you very much for sharing your
Pleasure.
story
Thank
and
you
insights.
very much
Thank you
indeed.
very much indeed. Paul Clark,
Thank
everybody.
You.
Thank you.